of sight is 90 degrees to the vertical or to the gravity direction. So if we take this illustration we have here, we have point A, that is our benchmark or a point whose reduced level is known. We have placed our machine at I1. We have read the stuff at A, and the reading of the stuff at A is R1. And therefore, for us to establish the reduced level of that line of sight, or to establish the height of collimation, then we shall add our staff reading R1 onto the reduced level of point A. Of course, we have defined our reduced level of point A with reference to an agreed datum. It could be mean sea level or it could be any other datum. So that's why here we say that the HPC, which is the height of collimation, will be equal to the reduced level of A, elevation of A, plus the staff reading at point A, which is R1. Now, once we have established the reduced level of that line of sight, if we rotate our level until we view a staff at point B here, which is labeled as CP, if we have already established the elevation of the horizontal line, which is the line of sight, it means for us to be able to find the reduced level of B, we shall take the reduced level of the horizontal line or the line of sight minus the staff reading at point B, which is R2. So it means the reduced level at point B shall be equal to the HPC minus R2. Is that clear? Is that clear? We compute the HPC from the reduced level of point A and the staff reading at point A?
Yes.
Okay, so we'll start from there. We have our staff at point A. We have our level at the at point I1, relatively halfway between point A and B. And we know the reduced level of point A. To find the reduced level of that horizon that runs just above the tripod, we take the reduced level of point A and we add the staff reading at point A, which is R1. And that gives us an HPC, which is equal to reduced level of point A plus R1, where R1 is the staff reading at point A. Is that clear, Lydia?
Yep. Yes.
Now, after we have established the elevation of that height of collimation, we know that our point B is R2, which is the staff reading at point B below our line of sight. Place our staff at point B, And the reading, the staff reading is R2. For us to be able to find the reduced level of point B on the surface of the Earth, we take the reduced level of the line of sight minus that distance between the line of sight and point B on the surface of the Earth. And that is given by R2, which is the staff reading at point B. Is that clear, Lydia?
Yes.
So now it means we have established now the reduced level of point B. So if we change our staff from position, rather our level from I1 to I2, we still have our staff at point B. Remember we said at the change point, turning point, we have both a back sight and a forward sight. So if we move our level to point B, rather to I2, we take a back sight now. Remember, it's the first reading with the new instrument. goes here. So we have the back side here minus the interside. So we have 4.5. But remember now, this rise is from CP1 to the bridge. So here it means we shall use the reduced level of CP1. We add on our rise to be able to get the reduced level of the bridge, or the bottom of the deck of the bridge. Cassidy, can you confirm that? Is that the reduced level you have for the bridge?
Yes.
Yes, it's the one.
Okay. Okay. So now if we go to CP2, we shall have a minus. That means we have a fall. So we shall have this minus this. And then that we shall add on to the reduced level of the bridge. So that will be the reduced level of CP2. Cassidy, please confirm.
Yes.
Yeah, that's the one.
Good. So then is the next a rise or a fall?
A rise.
Good.
The rise.
Next is a rise. Back side is bigger than interside. So we add this onto the reduced level of CP2. And then the next is a rise 2. So we do this minus that. Positive, then we have this plus that. And then the last is a rise 2. So we have this minus that. And then we add that onto the rise. Cassidy, can you confirm that that is what we had?
Excuse me? Actually,
Yes.
the last two reduced levels are different from what we have.
The last two are different from what we have.
Yeah, from what Cassie Henry had.
Ah, yes. Now, the last two, these two, I think I know where the issue is. So we have this, which is the fall from CP2 to peg B. But when we were adding here, we added to peg A and not to CP2. So this should have been G6. CP2 plus E8. And then this should also
Excuse me, can you explain more about that? I'm not getting what you're doing.
okay. We are okay up to peg A.
Yes.
Are we okay up to peg A? Okay. Now remember we said to find the rise of what its backside minus forward. So here where we have intersides, we shall take our intersides as the forward. So here at peg B, we have the backside at CP2 minus the interside at peg B. And that is the rise. This rise is not from peg A to peg B, but it is from CP2 to peg B. And that's why when we are finding reduced level here, we shall take the reduced level of CP2, then we add the rise. Is it okay now?
Why can't we just use the intersides to compute the rise?
Sorry?
Why don't we just compute the rise between peg A and from peg A to peg B? Why do we have to go back to the?
We can't compute the rise or fall from between A and B because it is the backside reading that we use to establish the height of collimation. So if we had wanted to do the way you want us to do it from peg A to peg B, then we will say our rise here between peg A and peg B. Our rise here shall be the reading at A, which is this, minus reading at B. If we do that, then it means this change in the rise is between A and B. And then if we do that, we'll go back to what we had done. Instead of adding it to CP2, then we add it to peg, the reduced level of peg A. But remember, like I said, is we use the backside reading to establish the reduced level of the line of sight. That's the principle. So if you decide to do it this way here between A and B, they are both intersites. Well, instrument station is the same, then you will add your rise to peg A and not to CP2. If you decide to do it the other way, if we follow the HPC approach, then you shall add it to CP2. Is it clear?
Yes, it is.
Madam,
Okay.
excuse me, madam.
Yes, please.
From the height of collimation method, I still don't know how you got the reduced level at change point 2.
In the height of collimation method.
Then you have to add like the reduced level at the bridge, then plus the foresight reading that was on, plus the foresight reading that was 1.230 to get the reduced level.
You repeat your question again?
Using the height of collimation method.
Yes.
I still don't get how you got the reduced level of the change point.
Do it together again here. Using the height of collimation. So the first height of collimation is the reduced level plus backside.
Yes.
That is.
Yes.
Then reduced level of CP1 will be the height of collimation minus the foresight. Is that okay?
Yes.
The height of collimation at CP1 will be reduced level plus backside.
Yeah.
That's okay?
Yeah.
The reduced level here will be the height of collimation minus the intersight.
Yes.
Reduced level at CP2 will be height of collimation minus the foresight.
Okay.
Is that okay? Then height of collimation at CP2 will be this reduced level plus the backside. So at every backside, we have a height of collimation because then the instrument height has changed, the line of sight has changed, so we have to re-establish the reduced level of the line of sight.
Okay, madam, understood.
Is that clear?
Yes.
Okay. So I think we could stop here for today. And in the next class, we shall finish up with the leveling. This is just part of the computation. After we have computed, remember we said we start at a known point, we end at rather a known point. So it means if here if we compute, let me finish this, we do this minus that, then again this minus that, then this minus that. If here we have computed 199.835, probably the known could have been 1199.830. Maybe the difference of this minus that. So if this is what you have computed and this is the known, it means there's a difference of 5 millimeters. So how do we deal with this deviation? So in the next class, we'll see how to distribute that correction, but also how to check if we are within allowable or if we are beyond. If, for example, the requirement in your terms of reference is that you fix your height to 2 millimeters, this is 5, you're clearly beyond the allowable. So it means you dismantle and re-observe until you have the required. But if it is within the allowable, then we will see how to distribute this error to adjust the readings that we have computed. And then we add some of the other corrections that we may have to apply or that affect our readings. And I am thinking we should work with Sonia to fix that class this week so that next week we start on another topic. So we'll work with Sonia and then she will communicate to me when we can have the other class this week. So we are able to start on a new topic next week.
Excuse me.
Yes, please.
Someone wants me to share my screen one more time, please.
Sorry?
Someone wants me to screen share my screen one more time.
I can't hear you properly.
There's someone.
Preferably next week.
Like, he wants me to screen share like one more time in a sec.
Ah, that's okay. You can screen share. I have stopped screen sharing. And if you check Uren and Price surveying for engineers, there's a lot of examples about leveling. You have the observations, you're required to compute the reduced levels. They can give you the reduced levels and you work backwards to compute the staff readings. So I urge you to do as many examples as possible in the Uren and Price text. So if there is no any other question, I shall wish us a good day and I'll wait for communication from Sonia.